Actually, electrochemistry is the branch of chemistry which deals with the relationship between electrical energy and chemical changes. During electrical energy, what are the chemical changes taking place in redox reactions? What is meant by redox reactions? So, redox reactions are reactions within the same reaction, both the oxidation and reduction takes place. Both the oxidation and reduction takes place. How chemical energy produces in redox reaction can be converted into electrical energy, or how electrical energy can be used to bring about a redox reaction which is otherwise non-spontaneous. That deals the electrochemistry. So mainly it explains during the redox reactions how electrical energy converted into the chemical energy, how electrical energy can be used. When electricity is passed through the solution of an electrolyte to bring about a redox reaction known as electrolysis. What is meant by electrolysis? So when electricity is passed through the solution of an electrolyte to bring about a redox reaction known as electrolysis, and the arrangement is called an electrolytic cell, and when electricity is produced by redox reactions. Electricity is produced by redox reaction. Gives rise to what are known as electrochemical cells or galvanic cells or voltaic cells. So when electricity is passed through the solution of an electrolyte to bring about a redox reaction known as electrolysis, and the arrangement is called as electrolytic cell, and when electricity is produced by redox reactions, it gives rise to electrochemical cells or galvanic or voltaic cells. In electrolytic cell, the flow of electricity through the solution is due to the flow of ions, due to the mobility of ions. And in an electrochemical cell, the flow of current is due to flow of electrons. In electrolytic cell, the flow of electricity through the solution is due to the flow of ions. But in electrochemical cell, the flow of current is due to the flow of electrons in the external circuit, and the flow of ions through the solution in the inner circuit. That is the difference between electrolytic and an electrochemical cell. The flow of current due to movement of ions through the solution of an electrolyte is known as electrolytic conduction. Electrolytic conduction. Thus, the three main aspects of study in the branch of electrochemistry are electrolysis, electrolytic conduction, electrochemical cells. Three aspects. What is electrolysis? What is electrolytic conduction? What is electrochemical cell? First, we will discuss about what is electrolysis. Electrolysis is a process of decomposition of an electrolyte by the passage of electricity from an external source through its aqueous solution or molten state for performing chemical reaction. Molten states for performing chemical reaction. It requires the use of electrolytic conductors. It means nothing but electrolytes in the form of an aqueous solution or in the molten state, as well as electronic conductors, electrodes. Electrolytic conductors are known as electrolytes. Electronic conductors are known as electrodes. Electrodes are essential components of an electrolytic cell. So without electrodes, conductivity may not possible. Actually, two metal electrodes are dipped in an electrolyte and are connected to a source of electricity, that is battery. The electrode which is connected to a positive pole of the battery is called anode, and the negative pole is known as cathode. You have to remember here, positive pole is known as anode. Positive pole of the battery is known as anode. At anode, oxidation takes place. At anode, oxidation takes place. Negative pole of the battery is known as cathode. Negative pole of the battery is known as cathode. Either oxidation occurs at the anode, when reduction occurs at the cathode. Reduction occurs at the cathode. Okay. So anode having positive charge, hence it attracts anions. Cathode having negative charge, it attracts cations. You have to remember, anode attracts anions, cathode attracts cations. A, anode attracts anions, cathode attracts cations. But anode having positive charge, cathode having negative charge. Don't confuse it. You have to remember, in the electrode which is connected to a positive pole of the battery is called anode. It attracts anions having the positive charge. At anode, oxidation takes place. Negative pole of the battery is called cathode. It attracts cation, it having negative charge. At cathode, reduction takes place. Reduction takes place. So this is the electrolytic cell. Suppose this is the cathode. Cathode attracts cation, but it's having the negative charge. See here, are you observing here the electrolytic cell? So in the electrolytic cell, cathode having negative charge, but it attracts cations. So cations are coming towards cathode. Anode having negative charge, anode attracts electrons, negative charges. Negative charges. But it's having positive pole, it attracts negative. So opposite poles are attracted. Opposite poles are attracted. So what are the chemical reactions takes place here? When an electrolyte is dissolved in water, so this is the water solvent. Electrolyte is dissolved in water, are taken in the molten state, is dissociated into charged species, charged ions. Charged. If sodium chloride is dissolved in water, what will be happens? It breaks down as a Na plus and then Cl minus ion. Like that. On passing electric current, cations moves towards cathode. So here you can clearly observe cations are moving towards cathode and anions are moving towards anode. Anions are moving towards anode. After reaching at their respective electrodes, reaction takes place in between. reaction takes place in between. Oxidation occurs at the anode while reduction takes place at the cathode. Reduction takes place at the cathode. So for example, electrolysis of sodium chloride, it consists of Na plus and then Cl minus ions. And passing of electricity, ions moves towards their respective electrodes. Because cations are moving towards cathode, anions are moving towards anode. Here, Na plus is the cation, Cl minus is the anion. But sodium metal is liberated at the cathode. Sodium metal is deposited at the cathode and chlorine is evolved at the anode. Because at the cathode, what will happen? At the cathode, sodium ions, after reaching sodium ions, it takes electrons. So cathode having negative charge, right? It took electrons and then converted into sodium. Reduction takes place. At anode, chloride ions releases electrons, removes electrons. Chlorine is released. Oxidation takes place. The electrons released at the anode pass through the external circuit and reach the cathode, so that Na plus sodium ions can be reduced. Thus, an oxidation reduction occurs at the anode and a reduction reaction at the cathode. Reduction reaction at the cathode. So, see, like this, many examples are there. If suppose electrolysis of an aqueous solution of copper sulfate, if we are taking copper sulfate in electrolytic cell using platinum electrodes, reduction of the cupric ions occurs, cupric ions converted into the copper and is deposited on the cathode. Simultaneously, release of oxygen at the anode, like this here. With the water molecule H plus OH minus ion is there. Both the sulfate and then OH minus ions are present nearer to anode, but sulfate ion is bulk. Since the discharge of potential of OH minus ions is lower than that of sulfate ions. Because sulfate ion is the bulk, OH minus ion is the, at the same time, discharging potential of the OH minus ion is lower, which having a less discharging potential, it can be easily discharged. So OH minus ions are discharged with respect to sulfate ions. And sulfate ions are charge carriers in the electrolytes. This is the introduction about the electrochemistry. Introduction about the electrochemistry. Now we will move to the electrodes. Which kind of electrodes are they? What are the reference electrodes, and then we will discuss.